In this section, we're going to discuss one of the case studies, the greatest common divisor. The GCD is the largest integer that divides two other integers. Divides means that the divisor goes into the dividend with no remainder. This means that for any two numbers, m and n, there is some integer, k, such that k divides m and k divides n. Another way to look at it is that m equals some integer a times k, and n equals some other integer b times k. M and n are both multiples of k. An algorithm for determining the greatest common divisor has been known since ancient times, and there have been many others since. So there's not a unique solution for finding this. There are just some better ones. This is a situation of deciding which approach is best. Sometimes that has to do with the amount of time it takes to compute, the amount of memory necessary to compute, or perhaps the mathematical understanding of the programmer. One approach is to start with the value 2 and see if it divides both m and n. If so, it is a common divisor, but it may not be the greatest common divisor. We would remember that number, add 1 to it, now it becomes 3, and try again. Each number that evenly divides both m and n, we would remember as the greatest common divisor found so far. Once the divisor becomes equal to the smaller of m and n, we can terminate the loop because the divisor couldn't possibly be any higher. Someone may wonder, shouldn't we stop sooner? Well, no, we want to stop with the smallest because it's possible that the second number is also evenly divided by the first. For example, greatest common divisor of 5 and 20 is 5 itself, and that would be one of the numbers. A loop is essential to program this solution. M and n are not known beforehand, so our routine to do the solution must be able to handle any two integers m and n.